In alkyl halides, a halogen is bonded to a carbon. For example, this is an alkyl halide. Chlorine is bonded to a carbon. This is another example of alkyl halide. Bromine is bonded to a carbon. This is another alkyl halide. And iodine is bonded to a carbon. Naming alkyl halides is similar to alkanes. First, we find the longest carbon chain. For example, in this molecule, the longest carbon chain has 3 carbons. Then we number in a direction that gives the first substituent lowest possible number. 1, 2, 3. This is 2-chloropropane. In the second molecule, the longest carbon chain has 5 carbons. And we have to give the first substituent, which is methyl group, the lowest number. It's 1, 2, 3, 4, and 5. And this molecule is 3-bromo 2-methyl pentane. Bromine comes first because the side chains come in alphabetical order. For this molecule, the longest carbon chain has 7 carbons, and we number from the left side to give the first substituent the lowest possible number. So it's 1, 2, 3, 4, 5, 6, and 7. Then we list the side chains, the substituents, in alphabetical order. 5-bromo, 2 and 3 and 3 trimethyl heptane. For simple alkyl halides, we can use common names. So alkyl comes first, and the name of halogen as halide comes second. For example, common name for this molecule is methyl chloride. And systematic name, IUPAC name, is chloromethane. For this compound, common name is ethyl chloride. And IUPAC name is chloroethane. Common name of this compound is methylene chloride, and IUPAC name is dichloromethane. Dichloromethane or methylene chloride is a common organic solvent. If halogen is bonded to a methyl group, to a CH3, this is a methyl halide. For example, CH3Cl is a methyl halide. If halogen is bonded to a primary carbon, we call it a primary alkyl halide. And what is a primary carbon? Primary carbon is a carbon which is bonded to one other carbon and 2 hydrogens. So for example, here This carbon is bonded to one carbon, this alkyl group, and two hydrogens. This is a primary carbon, and chlorine is bonded to a primary carbon, which means this is a primary alkyl halide. If halogen is bonded to a secondary carbon, this is called a secondary alkyl halide. And secondary carbon is a carbon, like this carbon, which is bonded to two other carbons, two alkyl groups, and one hydrogen. If halogen is bonded to a tertiary carbon, we have a tertiary alkyl halide. And a tertiary carbon is a carbon like this carbon, which is bonded to three other carbons, three alkyl groups. Carbon which is directly bonded to the halogen is called alpha carbon. So this is alpha carbon in the first compound. It's the alpha carbon, the carbon which is bonded to chlorine, and alpha carbon bonded to chlorine. In the first compound, this compound, alpha carbon is a primary carbon because it's a carbon which is bonded to only one other carbon, one alkyl group, and two hydrogens. In the second compound, alpha carbon is a secondary carbon because alpha carbon is bonded to two other carbons, two alkyl groups, and only one hydrogen. And in the third compound, alpha carbon is a tertiary carbon because it is bonded to three other carbons, three alkyl groups, and no hydrogen. Identify the type of alkyl halide in the following compounds. For A, this is the alpha carbon. Okay, the carbon which is directly bonded to the halogen is alpha carbon. Now, what type of carbon is alpha carbon? Alpha carbon here is bonded to two hydrogens and one other carbon. So alpha carbon is primary carbon, and bromine is bonded to a primary carbon, so this is a primary alkyl halide. In B, first we find the alpha carbon. This is the alpha carbon, the carbon which is directly bonded to the halogen, to the iodine. And this alpha carbon is bonded to two hydrogens and one other carbon, this carbon. So this alpha carbon is a primary carbon, and halogen, iodine, is bonded to a primary carbon, which means this is also a primary alkyl halide. In C, first we identify the alpha carbon, which is this carbon. And what type of carbon is this alpha carbon? This carbon is bonded to 1, 2, and 3 other carbons, which means this is a tertiary carbon. And since chlorine is bonded to a tertiary carbon, this is a tertiary alkyl halide. In D, first we identify the alpha carbon. Alpha carbon is the carbon which is directly bonded to the halogen. This is the alpha carbon. And this alpha carbon is bonded to one hydrogen and two other carbons. So the alpha carbon is a secondary carbon. And bromine here is bonded to a secondary carbon, which means this is a secondary alkyl halide. Chloride, bromide, and iodide are good leaving groups. And for that reason, alkyl halides are usually used as substrate in substitution and elimination reactions. Organohalides have many applications. For example, many of them are toxic and used as insecticides. Many of them act as hormones, like these three examples. Many of them function as dyes. Many of them have clinical applications. For example, these drugs. And some organohalides have been used in the food industry. For example, this compound, Splenda.